So this is Bhukesh Anil. So today our topic is in the subject of HVDC, high voltage direct current. So in that I am discussing this topic AC, DC, load flow, and understanding the Jacobian matrices with the controlling of HVDC. That is nothing but so discussion of some few minutes is very understandable and clear for every one of us. We know already the HVAC system, that is nothing but high voltage AC system. Basically, we need the power in the high voltages only, because when high voltages will come through the transmission line to our home, the consumer will be grasp this more current in less power. So one high voltage current will be there for transmission, means millions of consumers will be using this. So here HVAC, what is the drawback of HVAC? So we know already HVAC, but some more things, that is nothing but more losses plus some extra shocks, corona effects, and all those things will be happens in this case. And here more power consumption, more risk will be there in this case. That is nothing but HVAC, that is high voltage AC current. This is like this transmission line will be appear in the different phases. This is the HVAC. You can consider it as a as a electrical person. You can see any transmission line. That line, which type of line means like this three type of insulators will be present, means that is called the HVAC system. So this is the high voltage AC system. So directly AC will be transmitted through this transmission line. And coming, why we are using, I have already told now, coming to the point of HVDC. Here we are converting the AC current to the DC current, and we are using this current as a consumer point of view, where we are using some converters. Converters are nothing but the power which can convert from one phase to another place. That is one phase to another phase. That is nothing but AC to DC or DC to AC. We have already known those points already. So that is the thing. Here I can show the thing which is nothing but this is the generation point of view. And here generation point of view, and this is the normal. If these points will be not there, on the time the point will be called HVAC. But here we using the converters. These converters is nothing but AC will be converted into DC. That is nothing but AC converted into DC, means that is the rectifier. Here we are using, this is the HVAC system. Additionally, we are using this, that is AC to DC, and these are long lines here. And after that, the consumers, where the consumers will be there, nearer to them, that is the place. Which place will be that place, they can convert this DC into AC again, and they can use through the transmission line. So they can get AC current only. That is not issue, but the transmission will be safe and secure here, and more easy to transfer more and more thing. And here we are using the point that is nothing but reactance. We have already know that is reactive power, active power, all those things have now. So we are by changing some reactive power, by changing that reactive power, we are doing in middle of that thing, that is conversion of that AC to DC, and again in middle of those things will happens to transmission, and again DC to AC, and again goes to transmission. Like this is the substation near to us and substation to the. Okay. So these are the major differences, DC and AC. So this is the long distance period, that is HVDC, and this is short and medium distance, we know already, that is the HVAC, and this is the lower of losses, and this is the higher of losses, and this is requires the converter stations, that is nothing but the AC to DC and DC to AC. Doesn't require any converter stations here. That may be advantages or disadvantages. So here the higher influence of capital costs, that will be the major point. So capital cost is nothing but investment. In the initial point, we need some capital cost is more. So that is one of the disadvantages in the initial period. So in this, so this is the presentation cover the key main AC to DC flows, specifically focusing on the Jacobian matrix today. So what is the Jacobian matrix, and what will be things will be, I can show you after this thing. So this is the Jacobian matrix. So this is the complete Jacobian matrix. We have already known what is the difference, what is the thing we have P and Q are the two bar. We already know bus bar like that. So PQ bar here we are using, and this matrix we already know. In this Jacobian matrix we are using some equations and all those things. This is the complete matrix. We have already known the thing. And what is so in this why we are using means the Jacobian matrix are the vital understanding the power flow across the HVDC system. It can utilizes the relations between the voltage power variable, helping engineers to predict how changes in one impact others. This matrix serves as a foundation of various calculations, allowing for more efficient and effective load flow, proper utilization, ensure accurate modeling of system behavior and under different operational conditions, directly influencing efficiency, reliability. So by using these Jacobian matrices, we are predict all those things. So that will be the one of the main use of these things. So elements of differentiation we have already seen, rho, P by all those things here only now. So this is the differentiation. So that thing here, that is the element of differentiation already we know, already shown. And bus type, what is the difference of these bus types and all those things we already known. And what is the relations of these things, characteristics. Here the voltage and line commutation will be the main important type, and I can discuss now converters, control methods. So that is the control method. So control methods, in these control methods we have two type of control methods, that is VSC and line commutation converter. Two type of converters will be there. So I can show this, that is the thing, LCC, line commutation converter. At the same time VSC, voltage source converter. So I have already shown this, all the system in before that. This is the source, before the source I have rectifier and inverter again. So this already I have shown all those things. In that we are using this some things here, that is this is the LCC and this is the VSC. So that will be the thing. And in this variable management system we have used these type of desired systems will be major take parts in the HVDC system, and proper network systems will be used in the proper safety, and all those things will be considered in this system. And safety preferences and effects. The implementation of various control methods, the sufficient effects on the overall performances of HVDC system. Each mode influences how efficiently the system maintains the consistent power delivery, reacts to the disturbances and optimizes the operational efficiency. The interaction control mode with variable management directly impacts on the system reliability responses during the HVDC on all those systems. This is the system performance effects and all those things. And conclusion. So guys, we have already seen what is the HVAC and what is the HVDC and controlling methods and Jacobian matrix, all those things. We have already we have seen those things in my PPT presentation of book assembly today, and this will be the major part of our examinations also. And this is the main subject, main content of our thing, that is what is difference of HVAC, DC and all those things. It may be used for our exams also. So I have considered all those things and included some introduction part that will be also. And so this is the total thing what will be I have told today. So this is my conclusion. Thank you so much. Thank you all.